Moving on to the key aspects of regulatory compliance. A well-defined regulatory framework provides certainty for developers, facilitates project planning, and minimizes negative impacts on the environment and local communities. To achieve this, issues such as implementing technical codes and standards, promoting clarity and consistency in regulations, and removing unnecessary administrative barriers must be addressed. Looking at this implementation of technical codes and standards. Technical codes and standards should address issues such as design, collector depth, and spacing around thermal stability and compatibility with other infrastructures. Main technical considerations are shown in the table below. Collector design and sizing. The design and sizing of horizontal collectors directly influence the long-term efficiency of the collectors. Clear criteria must be established on the minimum spacing between collectors to avoid thermal interference, which could affect the performance of the systems. In addition, it is important to evaluate the type of soil and its thermal conductivities, as these characteristics affect the efficiency of the system. A good design should consider soil variation to optimize heat transfer. Techniques should also be implemented to prevent excessive soil compaction during installation, as compaction can decrease thermal efficiency and hinder thermal regeneration of the soil. Safety and quality control. Safety and quality control are essential for the safe and efficient operation of horizontal collector systems. The materials used for both piping and thermal fluids must meet high standards of durability and strength to prevent leakage or contamination of the subsurface. Installations need to follow strict quality protocols to ensure that there is no risk of fluid leakage or contamination, which could have negative consequences for the environment. In addition, the companies in charge of the installation must be duly certified, which ensures that they comply with the safety regulation and technical standards required for the implementation of these systems. Also, monitoring and maintenance is important. Continuous monitoring and maintenance of systems ensures their performance and longevity. It is necessary to establish clear protocols for regular inspection of the collectors to detect potential failures or deterioration in the systems before they become a serious problem. The use of temperature and flow sensors is key to monitor the thermal performance of the systems in real time, allowing for efficient energy management. In addition, detailed procedures must be put in place to quickly identify any anomalies in the installation and take corrective action. Regular maintenance not only optimizes efficiency, but also prolongs the lifetime of the system and ensures their proper operation over time. Promoting regulatory clarity and consistency. Lack of clarity and consistency in regulatory frameworks can be a major barrier to the effective deployment of horizontal collector systems. To promote widespread adoption, regulations need to be transparent, predictable, and harmonized across jurisdictions, reducing administrative burdens on developers and ensuring smooth project implementation. Regulatory challenges are the following. Fragmented regulations. In many countries, regulations vary widely at the regional and municipal level, creating uncertainties for developers. These discrepancies can lead to delays and increased costs, as developers must comply with different requirements in different jurisdictions. Also, there is the lack of clear guidelines for permitting. The absence of clearly defined permitting criteria can lead to lengthy and bureaucratic licensing processes. Without standardized guidelines, approval procedures can be unpredictable, deterring potential investors. Conflict with other regulations is another issue. Existing land use or water management regulations can hinder the installation of horizontal collector systems if they are not taken into account during the planning procedure. These conflicts can limit the feasibility of such projects and complicate the integration into existing frameworks. Moving on to the sustainability and monitoring. The sustainability of horizontal collector systems depends on proper planning, continuous monitoring of their performance, and minimization of environmental and social impact. An effective monitoring system ensures that collectors operate efficiently over time, preventing thermal degradation of the soil and ensuring their integration into other energy infrastructure. In this section, three main aspects are addressed: environmental sustainability and energy efficiency. Horizontal collector systems should maximize thermal efficiency while minimizing soil disturbance and environmental impact. Key challenges include thermal interference, affecting long-term energy storage, significant land use requirements, and potential disturbance to underground ecosystems. Sustainability measures include thermal modeling to reduce interference, seasonal heat exchange for thermal regeneration, and integration with other renewables. Environmental regulations help by setting impact assessment criteria, temperature variation limits, and revegetation practices. Efficient land use planning can also minimize conflicts by integrating installations with existing infrastructure or using low-value agricultural lands. Monitoring and tracking strategies. Continuous monitoring for horizontal collector systems allows their thermal and environmental performance to be assessed, ensuring their efficiency and preventing long-term problems. Installation of sensors at key points record groundwater temperature and heat flux, detecting abnormal variations. Regular audits compare operational data with theoretical models to optimize the performance. In addition, monitoring of soil properties and subsurface thermal recovery helps minimize environmental impacts and ensure the sustainability of the system. Lastly, we're looking at continuous improvement mechanism. The data obtained from monitoring should drive continuous improvement strategies to optimize the performance of the horizontal collectors. Operational adjustments such as modification of flow rates and load discharge strategies allow the system to adapt to the observed thermal condition. The information gathered can also contribute to updating regulations, refining standards for future installations. In addition, the use of artificial intelligence and predictive modeling makes it easier to anticipate problems and optimize performance before failure arises.